The next thing that we're going to look at is set operations. And all of these would require a universal set if we're using complements. But what are the common set operations? The first one is the union of two sets. Which simply means the set that contains all elements of A and all elements of B. So the union of two sets A and B would simply be the set that contains all elements of A and all elements of B. In terms of a notation, we call it A and put U and followed by B. Union is like addition in regular algebra. Union in set theory is like addition in regular algebra. The intersection of two sets, A and B, we write it as A upside down U followed by B. This is the set that contains only elements that are common to both A and B. Third case, the complement of the set. Now keep in mind, I mentioned earlier, anytime we have complementary sets or we have complements, we need to know what the universal set is. So the complement of the set A will contain elements in U, and the element cannot be a part of A. So going back to Venn diagrams, if I call that to be set A, that's U, everything that is not part of A will be in A complement. So the red dot will be in A complement. The black dot will be in A, but it is not going to be in A complement. So if the element is in A, it cannot be in A complement. If it is in A complement, it cannot be in A. So by all means, A complement is not A. Anything that is not A. So easy hint, A complement simply means not A. The first point that I would like to write for any set A union empty set would equal to that would equal to A. Why? The reasoning. We know the empty set contains nothing. And the set A, let's say it has the empty set because every set contains the empty set. And then a bunch of other numbers. You know, we'll just say 1, 2, whatever. I'll just put it as an example. Well, I want to combine them and I want to write A union empty set. Well, if I combine nothing with nothing, I still have nothing. So there is that nothing. And 1, 2, 3. But we don't have to specify that empty set. I can simply write it as 1, 2, 3. Writing it as 1, 2, 3, ... comma empty set. It's the same as saying 1, 2, 3, ... It is implied that every set will contain the empty set. So if I have A union empty set, I'm going to get the set back. But writing it as A, it's the same as saying A and containing the empty set, one and the same. So for any set A intersect empty set would equal to, so the empty set will be equal to A intersect empty set. Those are two remarks, and we can go on to an example. So here I would like to find the intersection and union between two sets A and B. I'm not going for the complement yet because anytime we have complements, I've got to come up with the universal set also. So A union B would contain all the elements that are common to both sets. Sorry, that's intersection. Contains all the elements of A and all the elements of B. So the elements are, I've got 1 here, 1 there, so 1. 2 here, 2 there, I've got 2. And 3, I've got 4, and 5, 7, and 9. Keep in mind, I'm not repeating elements. The reason being, I'm not defining the set. I'm finding whatever that is common between it. Excuse me, I'm just combining the two sets together. So I needn't specify the repetition. When I combine it. What about A intersect B? A intersect B would mean elements that are common to A and B. I confused myself. when I was talking about A union B, because I started shading the elements, if you look at the shading that I did, I shaded 1, which is common to both 1 and 2, B, that's the elements that are common to both A and B are 1 and 2. So I'll put 1 and I would have 2. So A intersects B, which contains all the elements that are common to both A and B, has the elements 1 and 2. Suppose I have the set 2, 4, 6, 8, and B is X, where X is member in N. N is simply the set of all natural numbers. If that is the case, what is a union B? Well, I know the set of natural numbers would be 1, 2, 3, 4, ... Well, I've got 1, 2 is in both A and N, so I put 2. Got 3, 4, 6, 5, 6, 7, 8, ... I'm just combining the 2 together. Well, if you think about it, a set of odd natural numbers, a set of even natural numbers, both are part of the set of natural numbers. And 2, 4, 6, 8 are even numbers, so it better be there when we combine in A union B. What is common between A and B? Well, I have the set of natural numbers, and it's 1, 2, 3, 4, 5, 6, keeps on going. What is common between A and the set of natural numbers? I have 2, I have 4, and of course I've got 6 in A. So 2, 4, 6, and 8. So A union B, we're simply going to combine all the elements of A and all the elements of B and put it in one set. Well, I've got 1, 2, 4, 9, A, B, and C. So let's merge them together. Mind you, we don't have to repeat. Typically, we're not repeating because we're not defining a set. If I defined it with repetition, that's a different story, but I'm not defining. The intersection would contain the elements that are common to both. Well, I see a C there, and 2 is here, 2 is there. Those are the only 2 elements that I see in common. So A intersects B will be C, 2. So the union of the 2 sets will be -1. Well, let me write it this way. -3, -2, -1, 0, 1, 2, 3, 4, 5, 6, 7. Mind you, order doesn't matter. The intersection would contain the elements that are common to both A and B. Well, there is nothing in common between A and B, so intersect. Now, I have the set A, set B, and in this case, I have the universal set as well. And you've got to keep in mind the universal set must contain the set A and the set B. And it does. Now, I want to find, let's say, a complement. I want to find everything that is not in A, but it's in the universal set. Well, let's see. I'm looking at you and I want to exclude everything that is in A. Well, what does A have? A has the element A, B, -1, 1, 2, 5. So everything that A has, a complement cannot have. So I will end up having 3, 4, C, D, 9, 10. Suppose I want to find a complement intersection B complement. That would mean I need to find a B complement. So since I have the universal set already, I can look at the universal set and come up with the elements that would be in a complement. So B has 1, 2, 3, 4. So I just have to get rid of 1, 2, 3, 4 and the universal set. Whatever elements that I leave behind will be in B complement. So I will end up having -1, 5, A, B, C, D, 9, 10. We're not done yet. All I did is find B complement. We want to find whatever that is common between A complement and B complement. Well, I don't see 3 in common between the two. I don't see -1 in common. I don't see a 4. I don't see A, but I do see the letter C. I see D in common. I see the number 9 in common. I see the number 10 in common. So A complement intersect B complement is simply C, D, 9, 10. A complement union B complement we already have A complement and B complement, so we just want to combine them together. I have -1, 3, 4, 5, A, B, C, D, 9, and 10. So A complement union B complement will be those elements. What is A complement union A union B complement union B? So this would equal to the universal set U. If you can't see it right away, don't write it out in the roster method because we have a lot of elements. Think about it using Venn diagrams. So A, B, well, if that's A, everything that is not A will be a complement. So which would include B as well. Great. And if I look at B, the one in blue, I'll write it as a complement. B, guess I'll pick red. If whatever I have is B, everything that is not B will be B complement. So B complements. And I want to put them all together. Well, which would mean I'm picking that part, that part, that part, putting them all together, ignoring duplication. Well, if you combine them all together, what do we get? We get the full universal set. We want to find A intersect B complement, and oftentimes people might say, well, this is the same as A complement intersect B complement. It is not. So you're taking the intersection first and you're looking for the complement of that entire set. The very first step is to look for the intersection. So A intersect B will be 1 and 2. And we want to find the complement of A intersect B. In other words, we're going to pick the set U, which is the universal set, get rid of all the elements that are in A intersect B, then I'm going to get A intersect B complement. So let's see, I'm going to get rid of 1, I'm going to get rid of 2. I will have -1, 3, 4, 5, A, B, C, D, 9, 10. If you observe carefully, this is something we saw earlier, going back a few steps. Part 3, problem 3. That's from earlier. That is A complement union B complement. And if you observe, they are one and the same. So A intersect B complement is the same as A complement union B complement. One may ask, well, why should we remember this? Sometimes finding A intersect B complement would be easier than finding A complement union B complement. So we just have to make a wise choice on which to pick. If we know this remark, then it's just straightforward. If I use the same logic, what would a union B complement equal to? This would simply equal to a complement intersect B complement. Think about it this way. Think about distributing the complements and think about complement as flipping. Well, if you flip intersection, which is upside down U, you will get U. That gets flipped. So if you have U, you get intersection. Very neat properties or remarks, but they have a fancy name. These are called De Morgan's laws. Very useful in upper level maths, but it's a very good property. Again, one may ask, well, why do I have to know both? Sometimes using the left-hand side or computing the left-hand side might be easier than computing right-hand side. So that's why. Here we have a set A, a set B, and U is all natural numbers in set builder form. I want to find the complement of A. That would mean everything that is not in A, but they are in U. So how about the number 5, 6, 11, 12, 13, 14, ... Because the set of real numbers contains 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, keeps on going. So I write U in roster form. I'm writing all of them so that you get a better idea. Everything that is in A cannot be in a complement, so I'm just going to get rid of whatever I see in A. So that is going to give me everything that is in a complement, which is right there. The next step is to find B complement. So B complement would contain everything in everything that's not in B. So whatever that is in B must be excluded. I'm seeing 1, 2, 3, 4 in B. So I'm just going to exclude 1, 2, 3, 4. And that would give me 5, 6, 7, 8, 9, ... So I have B complement. Have A complement, I have B complement. I want to find their intersection. What is common to both? We have 5 and 6 that are common to both A complement and B complement. 7, 8, and 9 are in B complement, but not in A. So that's gone. Number 10 is in B complement, but it's not in A. So it's not in common. So what is in common would be 11, 12, 13, 14, ... The second case, we first find whatever that is in common and then take its complement. What is common between A and B? 1, 2, 3, 4. A intersects B, complement. Would simply be 5, 6, 7, 8, ...